Alright students, today we are going to look at shapes of graphs. So let's say that we have a parabola or a graph that looks something like this. Alright, and so here's the question. Could I cut this graph right in the middle? Could I cut it right in the middle? Where this side matches this side? And the answer is yes. If I fold this in half, this side will match this side. Therefore, this line that I just drew is called the axis of symmetry. Alright, or the symmetry line. Alright, so basically that's what it says. If I could cut something in half, then that has an axis of symmetry. Okay, so let's look at other shapes. Let's say I have a V shape like this. Could I cut this in half? The answer is yes. I can cut it right through the middle, right there. This right here is called the axis of symmetry again. Now, be careful and determine what axis of symmetry that is. So if this is 1, 2, 3, 4, this is a -4. This axis of symmetry is called the x equals -4 axis of symmetry. Just like up here, if this point here, if this was 1 and that was 2, this axis of symmetry would be x equals 2. Alright? And let's say I have something like this, where it's upside down. Let's redo that one again. Let's say I have a shape that looks something like this. Could I cut this right in the middle? The answer is yes. Alright, so this right here, whatever point this is, let's say this is 1, 2, 3. This is called the axis of symmetry. Alright, now axis of symmetries could also be horizontal. So if I have a shape that looks like this, could I cut this right in the middle? The answer is yes. So this is the axis of symmetry, and let's say this is 1, 2. So this would be called the axis of symmetry. Y equals 2, 2. Alright. If it's horizontal, it's going to be y equals that number. If it's vertical, it's going to be x equals that number. Alright. The next thing we need to look at is whether the actual graph is positive or negative. So let's say that I have a parabola that looks something like this. Alright. I need to know when the graph is positive. Alright, so positive means if I look at it from left to right, so let's look at it from left to right. Notice this is going down right in this section. So this is 0. So it's negative. It's negative in this area. It's negative when x is less than 0. So from this section here, this is negative, and that's 0. When is it positive? Well, it's positive when it's going up from left to right. So it's going to be positive when x is more than 0. Alright, so looking at the actual graph itself, it's negative when it's going down, and it's positive when it's going up. Let's look at another graph. Let's say I had something like this. let's say this was -2, this was 1, let's say that was 3, and this was 5. When is this graph negative? Well, if I look at it from left to right again, it's going down in this section here. So it's negative when it's less than -1. It's also negative in this section here when x is more than 3. See, x is more than 3, it's going down. Okay, when is it positive? Well, it's positive when x is more than 1, and that's about it. So when x is more than 1, right up until about here, but x is less than 3. All right. So we have it's negative in this area when it's less than -1, and when it's more than 3. It's positive when it's more than -1, but only up until 3. All right, just in this section. Let's look at another example. And by the way, before I forget, since this is the highest point, there's no other highest point, we call this the relative maximum. Since this is the lowest point that I can tell, we call this the relative minimum. Okay, so the minimum and the maximum. All right, so let's look at a graph here. Let's say I have something like this. All right, what would be, let's call this point A, let's call this point B and C. What would be the lowest point that we can see? The lowest point in this case would be point C. That's the lowest point that I can see. So we call this the relative minimum. Okay, what's the highest point that we can see in this graph? So notice how this is a line that goes up forever. I don't know what turns it will make up here at all, or on this side. So all I can say is that this is the highest point I can determine. So we call this the relative maximum. All right? While this is a low point, it's not the lowest point. The lowest point is C. All right? If I have this line, when is this graph increasing? Let's call this point A, B, let's call this C and D. When is it increasing? In other words, when is it positive? Well, it's increasing between, again, when it's positive, so it's between A, So when x is more than a, it's increasing here, right between a and b. It's also increasing when x is more than c. Okay? When is it decreasing? When is decreasing? Well, it's decreasing right in this area here. When x is more than b, but less than c. All right, we can write this like this: more than b, less than c. All right, in other words, if I go back to my other examples, right here, I should have said decreasing instead of negative. So this is decreasing, and that it's increasing. It's going up. All right, same with this graph below. The red, it's decreasing, it's going down in 2 areas, and it's increasing in this section. So I should say decreasing instead, and I should say increasing instead of positive. All right, hopefully that makes sense. So this one here has a relative maximum, and this one here has a relative minimum. All right, we're almost done with this section. There's one more item we have to look at. And these are called the end behavior. So let's say I have a graph that looks something like this. Just simple. And so consider this graph. It has an arrow here, an arrow here. I'm going to look at those end behaviors. So as you go to the right, as x increases, so as x gets bigger to the right, where is y increasing to? Is it going up or is it going down? In this case, it's also increasing. See, if you go to the right on the x, this y value is going up as well. That's an arrow, by the way. If I go to the left, as x decreases, if I go to the left, what happens to the y values? Well, they also increase. Is this always the case? No. Let's look at one example where this does not happen. Let's say I have a linear function. As x increases, so as x gets bigger, the y also increases. All right, now let's look to the left. As I go to the left, as x goes to the left, as x gets smaller and smaller, so as x decreases, what happens to the y values? Well, they get smaller. We call this the AND behavior. All right? Hopefully this makes sense. Let me know if you have any questions. I will see you soon.